8.6, graphing quadratic equations that are in the form of what you see written here in black, where it says graph f of x equals x squared minus 4x minus 5. So we're going to take a look at how do we graph quadratic equations that are what we call standard form. In lesson 8.5, you were doing what was going over here in green, and we determined that it was really easy to find the vertex by figuring out what number do I put in for x that causes the inside the parentheses to equal 0, and that would be my x coordinate of my vertex, and then the number on the outside ends up being my y coordinate of my vertex. And so it's pretty quick able to find that this would be 5 and 2. Well, when we have quadratic equations written in standard form like this, now we're going to take a look at a new formula. The vertex is actually found, this would be our x coordinate, is actually found by doing this. We have a parenthesis and it's a little formula. The opposite of b over 2a, comma, the function of the opposite of b over 2a. Okay. All right, so how do we do this? Well, to start with, to find our vertex, we're going to start with defining the x coordinate. So we start by doing this little formula of the opposite of b over 2a. Let's take a look at my equation up here. The opposite of b, a is the number in front of x squared, b is the number in front of x, and c is the plane number at the back end, just like I have written up here at the top. And as you know those things from the quote you're doing and working with the quadratic formula in lesson 8.2. The opposite of b is 4 all over 2, and a happens to be 1, and 4 divided by 2 happens to be 2. So the x coordinate of our vertex is at 2, so somewhere here. This is also our axis of symmetry too. So now let's find the y coordinate. All right, so how do you find the y coordinate? Well, up here I said f of x equals x squared minus 4x minus 5. Well, the vertex is f of the opposite of b over 2a. That's a fancy way for saying take this 2 and put it in place of x. And then we go from there. So you have 2 squared minus 4 times 2 and minus 5. So if I do my calculations, I'm going to say that my y will equal, y equals 4 minus 8 minus 5. And y of that vertex equals 4 minus 8, negative 4. Negative 4 minus 5 is negative 9. So now my vertex coordinate will be 2, comma, negative 9. And as we know from our work from before, we're going to plot this to negative 9 first. So I'll write 2, down 9, that's a 6, 7, 8, and negative 9 is way down here. Now, how do we do our work? Well, if I remember correctly, in our last lesson, didn't we do some things where we had and reviewed the patterns of parabolas? And if you remember, when there's nothing in front of x squared, those parabolas have that 1, 3, 5, 7, 9 pattern. So we go over 1, up 1, and over 1, up 3, and over 1, up 5. Now, the vertex is on our axis of symmetry, which it happens to be right here. So again, to remind you of that, if I have a dot that's 1 space away on the right side of the axis of symmetry, I have a dot that's also 1 space away on the left. 2 spaces away on the right means 2 spaces away on the left. And now there's 3 spaces away on the right, so 3 spaces away on the left. And now I'm going to draw my parabola here. A little tricky with a mouse. So I'm sorry that it looks so rough. But when you have a quadratic equation in standard form, we're going to take and do this little formula, the opposite of b over 2a. That tells me the x part of my coordinate for my vertex. When I take that answer, I plug it in for x into my equation, and I solve for y. That will tell me my vertex. Our vertex always lies on the axis of symmetry. The axis of symmetry here, our AOS, equals 2. The axis of symmetry is always the x part of the vertex coordinate. The axis of symmetry is always the x part of the vertex coordinate. So lastly, you're also going to be asked to identify some things while working with these parabolas. You'll also be asked to identify the y-intercept. Well, look at your parabola. Where is the y-intercept? It's actually at -5. So the y-intercept is at the coordinate 0, -5. And you're asked to identify x-intercepts. So when I look here at my x-intercepts, I have one that's at -1, 0. And then I have 5, 0. So I have two x-intercepts. And the third thing you might be asked to identify is whether we have a minimum or a maximum. So in other words, you look at the vertex. Now, where does everything in the parabola go? It goes up from there. That means the vertex is a minimum value. So we have a minimum here. So we have a minimum value on our vertex. So there's three things you'll be asked to identify: y-intercept, x-intercepts, minimum values. Let's take a look at another graph here. I realize we're reaching about 6 minutes, so we'll see how fast. Our axis of symmetry is also the same as the x of vertex. So we can calculate this as saying the opposite of b over 2a, and I'm going to change colors. So when I fill this in, now I have a negative in front of my x squared, so that means that's a is -1, b is 2. So I'm going to say that x equals the opposite of b, so -2, over, and then a is -1, so it's 2 times -1. And -2 divided by 2 times -1 is -2, so I have an x that has an axis of symmetry of 1. So the x part of my vertex is 1. How do I calculate that? Now I got to calculate the y for my vertex. So y equals, I have an opposite of 1 squared plus 2 times 1 plus 3. So now I'll do my calculating. Keep in mind, since this 1 is not inside parentheses, it's 1 times 1 is 1 squared, so that's 1, and then it's a -1. The negative is done last. 2 times 1 being 2, and then plus 3. And if I add all this together, -1 plus 2 is 1, 1 plus 3 is 4. So then the y-coordinate of my vertex happens to be 4. So my vertex is 1, 4. And my axis of symmetry then is on 1. So 1, 4 is right there. All right, so now again, a parabola has nothing but a 1 in front of the x squared, so that won't narrow and it won't widen. It's just going to follow my normal pattern. What does this negative in front mean? It means the parabola opens downward. So if I was to start calculating in a table, which we're not going to do, we want to use our power of algebra, and we're going to calculate, and we're going to just plot our dots. We know instead of over 1, instead of up 1, we go down 1 with a negative in the front, and over 1 and down 3, and over 1 and down 5. It goes right there. And then I have my axis of symmetry here. So I'm going to use the idea of symmetry to help me plot the other points. This is 1 space away, so I'll put 1 dot right there. This is 2 spaces away, dot here. 3 spaces away, dot here. And then I want to draw my parabola. And again, this is not the best drawn parabola. I'm trying to draw with a mouse and a computer, and it's not always the easiest thing to do. So I apologize for the sloppiness and mess on that. Okay, so let's identify some things. Let's identify our y-intercept. Our y-intercept is 0, 3. The x-intercept, there's 2, -1, 0. And then I have 3, 0. And then ask yourself, is this a maximum or a minimum? Since the parabola goes up to the vertex and then turns and goes back down, this is a maximum. Okay, that's it for what I have for you on this lesson. I'd like for you to do page 529, 13, 15, 21, 23, and 25. When you finish those 6 problems, be sure that you correct them. And then check with me for the second part of the assignment. So then do those 6 problems, correct them, and then check with me. All right, thanks. Let me know how I can help you.